रिकॉर्डिंग भी शुरू करनी है।
हाँ, रिकॉर्डिंग शुरू हो गया।
लेट तो ज्वाइन अदर्स, क्योंकि अभी यहाँ पे सिर्फ 11 लोग दिख रहे हैं।
Sir, can we start?
Yes, please. Whom I have to give presentation, right?
Naveen, Naveen.
Yes, given. Please check.
So meantime, you can ask them to join because some of the people are not at join.
Hello. Shall we resume with the presentation?
सर अपना आवाज बंद कर लो सर। ठीक है।
Rishi, please wait for 5 to 10 minutes. Let's people join again. Huh?
Okay, ma'am.
Yes, started. Start.
Yes, thank you. The next command is CPU support. So this command tells about the how much virtual CPUs that you have allocated to the virtual machine. You can see the total number of CPUs that we have allocated to the guest machines are around 16. So we have 16 CPUs to take the task for the application. So you can see also the name is the virtualization, means it is on virtual machine. So next command is to check whether the cloud core server is running or not. Just hit the command. So it will print the information about your currently running MEC Cloud Core. So the Cloud Core is ready means you can deploy the applications on the Cloud Core. So it is currently ready and capable to accept the deployment files. Status is running. So for it is showing how many times the cloud server uh, restarts. It is showing 33 means we restarted this cloud core 33 times and the age is 6 days. Now go to the edge server side. So we are on edge core. Just run the command MEC status edge core. It will show you the currently running edge side service that is used to manage the containers that are running on the MEC edge core side. If you want to check the Docker service, then run the command Docker application container engine. So this application is responsible for maintaining the containers that are running on the edge side. So it is currently active and running. So these are the containers that are running on the edge machine. So we talked about the varnish. This is a container. This is the same container that is pushed from the MEC Cloud Core to the edge side. The IP address is यहाँ से पेज कैसे खुलेगा ब्राउजर से कंट्रोल पे So this is the IP address of a MEC Edge core, and you can see the application has been opened now.
Right.
So let's talk about the deployments. So we are talking about the deployments, means the application deployments. So the MEC architecture uses the YAML format for the deployment files. So these are the files that are responsible for deployment of the VR application that we used for the 5G labs. Let me show you the content of one YAML file. So this is the actual format of the deployment of my VR app. So the left side on the column there is a tag, and right side there is a value. So both label and value are separated by a column. So this is fix the API version, kind mean deployment. This is our deployment. Again, we mentioned the name my app VR hyphen app hyphen deployment. You can also add the label anything. Replica mean one. The replica means how many pods or containers you want to create. We created only one, that is why we mentioned here numeric number one. Selector, there is no use. Match level my app. Then role means it will run on the cloud core. This is the container name by which the cloud core will create your container. This is the name. This is the image that is bundled. We have developed the VR application. This is the image name. My app hyphen VR Apache. This is the command after the deployment. This command will execute inside the container. And this is the web server port, that is 80. Suppose you want to deploy this YAML file, there will be no effect right now because we have already deployed on this machine.
So what is the location of this? Can you please give me the exact location?
Exact location, you can hit this command pwd, and this is the exact location. Slash root MEC deployments.
Can you please hold on? Let me go there.
Yes, sure. Everything is mentioned in the training manual for the MEC. You can refer that also.
Okay, sir. So we have to do VIM dot tiny
Tiny,
YM. Okay.
then this YAML file name. We have described each YAML file in detail in the training manual.
Got it, sir. Thank you.
Okay. So to deploy the YAML file, you just run the command MEC deploy, then your YAML file. As I said, there will be no any effect after running this command. See, mean unchanged. Unchanged mean this is already deployed. If you will change any label, any component, then it will take effect on the server. Otherwise, it will give you the unchanged prompt here. You have nothing to do on the edge side. Everything will be done at the MEC Cloud Core side. All the deployment will be pushed from the cloud server to the edge server. You do not need to go physically there. Just deploy it, the YAML, and it will push it to the edge side. That is where this command is showing MEC status nodes. See, the MEC Edge core is already connected with the cloud core. So nothing to do at the Edge core side. These all the deployment files for the MEC cloud server. If you will go one step back, you can see Edge core side deployments. So for the 5G lab, we use two use cases. One is caching the data from the cloud core pushed to the edge side, and second is the VR application that is deployed inside the container. So in the last class, summarized all the MEC again. So MEC architecture is built on the virtualization layer, that is KVM, and over the KVM we used this KVM to creating the virtual machines, and MEC Cloud Core, MEC Edge Core, both are the virtual machines. We can change the resources later if we required as per the application. So developer maybe develop any application that is very resourceful. You can increase the resources for these VMs. So we used open source Kubernetes that is responsible for the complete container based architecture and manages the pods on the cloud core side and on the edge side. So this is all about the MEC architecture. So if anyone any question, please ask. Hello. 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 Is there any question?
ठीक है. Next we have to do that camera. I hope there is no query related to this session. So if yes, you can type in that public chat. Otherwise, you can contact us also. So the next session is for camera. That will be taken by Naveen Gupta. Naveen ji, please. Thank you, Rishi sir. सब चीज़ के लिए बहाने हो रहा है घर पे नहीं हो रहा है कोई चाहिए नहीं So let's start the 5G AI camera. First of all, the features of the camera. It's 5 MB CMOS image sensor, low luminance and high definition images. It supports the 512 GB of SD card. Wide dynamic range is up to 120 dB and one digital alarm port, one one audio port and one audio output. How to log in the camera when it will connect to the 5G core network. So SMF will provide the IP address for the internet DN. Browse this IP on your browser, and the username and the password are given as admin and admin123. That will start the video streaming. There are two inbuilt features. One is line crossing, and one is intrusion detection. And these are the alarms you can capture from the camera itself. So the live demonstration. Now the IP address of the camera is 10.45.0.199. Log in this and you will get the camera feed. Some features, just like in configuration, go to the system config. These are the encode setting. Right now the camera is streaming for the 5M support. You can change your resolution according to your need, and it will up to 8M, 3840 into 2160. And
Sir, where can we find the IP address of this? We are not going.
when you will switch on the camera will connect to the 5G network, and the SMF session management function will provide you the IP address.
So
That
we
will be
have
changed.
to, yeah, we have to tail that log, smf.log.
Yes, tail hyphen f of Coral 5GS var log Coral 5GS smf.log. Any other thing?
Thank you, sir.
Okay. Although this camera supports the AI/ML analytics, so we have to provide the feed of this camera to the face recognition system, which is implemented on the uh, MEC camera. So here you can see this is the face recognition system. The IP address, whatever is applicable at your end, just log in it, and how to what it can do. These are the events which are capturing. When you will go to the phases, you can see here we have uploaded two phases. One is for blacklist and one is for whitelist. Where you can add, just add the face here, person name, their photo. You can upload from here, make some remarks, and whatever you want to do, that blacklisting or whitelisting. Wait for a minute. That will generate the alarm when the particular person, whatever is applicable for the whitelisting or blacklisting, will come. So here you can see alarm has been generated. Mr. Sunil Nair from Coral Telecom is in the blacklist.
Sir, how did we land on this page?
Pardon?
From the camera, how did we go to navigate to this page?
From the camera, this is the MEC.
MEC/dashboard.
Not the dashboard, just put the, just a second. This is the MEC.
Okay.
Here will be the username. Wait.
Admin experts.
And the password and the captcha. And login. Any doubt here?
Yes, sir, working on it, please.
Again,
So our system is not working. The MEC IP address is not working over here.
what is the IP series at your end?
28. 192.168.28.21 is our MEC.
Okay. We have deployed there three MECs. One is edge, one is camera, and one is drone.
Yes, sir.
Maybe at your end, the drone, this camera MEC is not installed. Please provide the remote to us day after tomorrow. Then we will do the needful.
Okay, sir.
Okay. And you are asking for how to find out the particular IP address of the camera. SSH the 5G core, and check first which SIM is installed in the camera. You can see here. Go to the manager page. Anupam, we are facing some problem. Are you getting my voice? अभी आ गया ना हाँ मैं आ गया हेलो या ऑडिबल नाउ पूछ हेलो मैडम I think some of them are left. Can you check that? Ki all are there or not? Madam, can we start? Hello, I am audible. Okay, I am starting the session. So here you can see what is the NC of the camera. Just go to the path. This log will show you what IP address is assigned to the particular SIM. You can browse this IP and get the camera access. Any question regarding the camera? Then we will go for the IoT gate.
So how do we have to deploy the code? Like in the on the first day yesterday, you told us that for the fire detection, we have to put some code over there.
Sir, can you repeat it again?
Yesterday in the starting session, somebody told us that for fire detection and some other AI kind of features, we have to deploy some code, and we can detect such things
Yeah,
like
sir.
fire detection and
What I told you, there is a face detection application is to be installed to somewhere. So I told you that maybe 1 or 2 days we will do that, and we are started to implement in different sites. I think your site is maybe tomorrow or day after tomorrow. We'll take a remote session and we will convey you how it can be done. And there is a link also we'll provide you to execute these facilities and all. Okay, so be with us next. I mean, tomorrow maybe or after tomorrow, PEC. Sorry, GNDU and PEC will taken. So other sites also planned. We are planned that
one by one we are
one by
finishing.
one because this is already we have implemented in 7 or 8 sites now. So other sites are online. Maybe today was one site that is completed. Again, maybe tomorrow your name and PEC is there tomorrow for the session. So we will do that certainly.
Okay.
So I think there is no queries related to camera. There is very simple thing. Just you have to check the AMF and SMF log, and after the registration and all, and how that face detection or that things will be implemented on your sites, and we'll let you know how to implement it. So now the session is for IoT gateway, and Naveen will take the session. So, so first of all, introduction the IoT gateway hardware. As you can see here, three SIM cards can be inserted here. Three nano SIM cards. There are four 1 Gbps LAN ports, one HDMI port, two USB ports, and these are the four antennas for the 5G connectivities. It's a 4x4 MIMO. And these two antennas, the back side, these are for the Wi-Fi antennas. And that will be powered on by the 12-volt DC. Now the specifications that I'll show you live. Log in the IoT gateway and you can see here the status bar. In status bar, you will get almost all the information regarding the network and regarding the hardware resources of the IoT gateway. So you can see here the IP address of the SIM. This is the modem manager. In the wireless section, you can see here my laptop is connected via the Wi-Fi to the IoT gateway. These are the system configurations. What is the serial number? What is the CPU? Firmware version? When it was up? And what is the RAM size? You can see here also in the memory section how much of the RAM is used for. And this is the SIM status which is connected to the IoT gateway. So yeah, here you can see the status is connected. Connection type is 5G NR 5G SA. RSRQ, RSSI, signal strength, which it is receiving from the G-Node B. IMEI, IMSI, International Mobile Subscriber Identity. You can see here the operator name, the operator ID, which is 00101, the private PLMN ID, cell ID of the G-Node B, and what the duplexing technology we are using. We are using N78 band, which is TDD. Again, the tag version and the location. In the modem information section, you can see the modem specification. How much of bands this modem can support. For 5G NR NSA, these bands will be supported. For 5G NR SA, these band will be supported. For LTE FDD and LTE TDD, these band will be supported. Then first of all, how to configure the APN, access point name, or DNN in the IoT gateway. Go to the network section and interface. You can see here the only one SIM is connected with this network, and what IP address assigned from the SMF to this particular SIM. Go to the edit And here you can see the APN name and the modem device. And protocol should be the modem manager. If you are configuring APN for the SIM, both IPv4 and IPv6 are can be selected defaultly. Then for the Wi-Fi settings, go to the wireless, and here you can see the already configured the SSID, pre-configured, and the encryption. So here you can see both the band can be supported 2.44 gigahertz and 5 gigahertz. Operating frequency can be changed. Hello. हेलो 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 उसमें माइक ऑन करो ऑन है मेरा तो इसमें माइक है ही नहीं ये ऑन कर लेना अरे ये स्पीकर है सर हाँ ठीक है ऑन कर लो हम लोग माइक्रोफोन कर लो अभी इससे बात करो बात करो कर दिया बंद हेलो आई एम ऑडिबल हाँ ऑडिबल बात करो
Yes, you are audible.
ओके आई एम कंटिन्यूइंग अगेन हेलो आ रहा है अरे फिर से हो गया सर नहीं आ रहा फिर आप बात करो हेलो 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 ये भी कोई ओपन सोर्स है बंद करना इसको My voice is coming. Yeah.
Yes, yes, please. Hello.
Okay. Should I continue? Some
Yeah,
problem is
yeah.
coming.
Okay, you can continue.
Okay.
If everything is okay, please continue.
So here you can see the encryption algorithms. All
Your screen
latest.
is not your screen
Okay.
is not visible.
Okay. Wait for a second. Sir, can you give me the rights?
Whom I have to give rights?
Naveen Gupta.
Okay, okay. Yes, given to you. Please check.
Okay. Then. So here you can see the in wireless security section, the encryption. All latest WPA support is available. And in the cipher section, you can use the TKIP and add the setting. So, some issue in sharing? बोलो. Sir, the screen sharing is not happening. Can you check it again? Screen sharing is not happening.
It's blank.
शेयर करो. कर तो दिया. आवाज आ रहा है? हाँ.
हाँ, आवाज आ रहा है पर स्क्रीन पे नहीं आ रहा है कुछ भी।
अगर मैं कर रहा हूँ लेकिन ये बार बार हट जा रहा है और इसमें बार बार मेरे को ऑडियो ऑडियो वाली प्रॉब्लम दिखा रहा है.
नेटवर्क इशू होगा ना, हो सकता है
नहीं,
आपको।
नेटवर्क इशू नहीं है सर.
हाँ, अब तो आ रहा है, स्क्रीन दिख रहा है।
सुबह से तो चल. ओके. आवाज आ रही है मेरी? नहीं आ रहा.
जी, आ रही है, आ रही है।
सर स्क्रीन बार बार.
हेलो। हेलो।
Rest of the settings in network SQMQoS. Here we can control the speed of the particular interface in IoT gateway. For example, here you can see this is the SIM interface. When you will enable the SQM instant, you can control the download speed and upload speed from the IoT gateway end. These are the VPN connectivities in IPsec tunneling. So you can connect this IoT gateway through the VPN tunnel to transfer the data in a encrypted format. So these are the settings, and these are the encryption algorithms which you can use up to AES 256. And these IPsec tunnels can be made in number of increasing order. These are not limited to the 5. Some other features in services, when you want to block the URLs, you can make the whitelist URL and you can make the blacklist URL. Just add here the URLs which you want to do the for the whitelisting, ever you want to do for the blacklisting. You can also access this IoT gateway via SSH. The password is same. You can log in by that. And also do some debugging. Here you can see the SIM is connected and the signal quality is 83%. This is the operator ID, operator name, IMEI, and this is the system information. Every system information. You can also do the firewall setting here. So these are some firewall rules which we have implemented. You can also do or implement these rules via the GUI. So here you can see in network section there is a firewall, and these are the traffic rules which are pre-configured, and you can add your own rules according to your need. DOS prevention is also possible from this firewall, from the IoT gateways firewall. You can also make the net rules. These are the settings. When you will connect this IoT gateway to the cloud, these settings are necessary. Some custom rules also you can make. Routing is also possible in IPv format or IPv6 format. You can make some static routes. And here, one more thing, system logs also are present on the GUI. System log and event logs. for further diagnostic. There is some other protocols available, just like the WireGuard VPN, to connect this IoT gateway to the other networks. So multiple type of encryption are also possible via this IoT gateway. Any question regarding the configuration of IoT gateway? बता दिए। VIP भी login हो जाएगा। So we can move further. I think there is no question. Next session. So we can move on to the next session. That is session one. अभी बताओ। So there is a break to 4:30 to 5. Then we can start other session, that is AI or ML camp and IoT in 5G. That is application integration. Shoaib sir, can you just stop the recording, because this section will start after a break. So that is up to 5 o'clock.
Okay, okay, okay,
Okay, we'll start at 5 o'clock sharply.
okay.
Yeah. So the next session is AOML, IoT in 5G application and integration. So far, actually, whatever we done, I mean, camera we done, again, IoT gateway and MEC we done. Any queries related to that, you can ask here in the public chat, and we are sharing your contact numbers also. You can ask directly also. There is any issues related, yeah, you want to know more about these things. You can directly also talk to us on that number which is in the public chat. So we'll start with the this AI and ML and IoT in the 5G application and integration. Mr. Neil Indranil will explain all the things to you. So please open, and in public chat you can ask questions. Even you can talk in this session also. Okay. So we'll start. Neil, please.
Good evening to all. I hope you are having a good day. My name is Engineer Sorikfar. I'm on behalf of Coral Telecom, and today we will be exploring the possibilities of AI, artificial intelligence, and machine learning in IoT applications in particular 5G domain. Although AI, ML, and IoT, all three of these topics do have a really vast domain, but as we are primarily focusing on 5G, actually, we are going to go by understanding what is AI ML. Right now, they are like hotcakes. We can see that every organization, every other individual is trying to get deep dive into AI ML and everything. But IoT is getting sidelined. But let me just make a statement here, which is that you cannot deploy any AI ML product or anything like that without integrating with IoT. I know it is quite a controversial opinion, but that's just my perspective, and I really hope if you appreciate it or like accept it, and I'll be more than open to accept your perspective too. Now let's start the session. So first and foremost, we'll be going through what I will be discussing in this particular session, how this particular session will go. I'll try my best to make this particular session interactive. Just so you know that I've started my research on AIML for an year now, and I'll not say that I'm quite well versed in that, but I'm more than capable in understanding all these things and everything, how they take place, everything. So we are going to understand the proper how this entire session will go. First, we are going to understand the overview of basic AIML techniques, the basic ones which are like the supervised machine learning techniques, the unsupervised techniques, the deep learning ideas of what I'm talking about. Like majority of the professors in the top IITs or something like that, they must have assigned their this house prediction model or breast cancer or breast cancer detection models. All these things are quite basic overview of how these AI ML techniques work actually. After that, we'll be moving towards the second topic, which is AI ML applications for 5G. As the companies are uh, really funding these particular AI ML projects, we have just seen that a lot of applications, let it be a software related to, and to all the way till the hardware related, and to all the way till the embedded level, all these things are trying to imply AI and ML in some way or another. I have a great example for you in which I'll be telling you how AI ML is just being applied in a software which was basically substituting of hardware. We'll get into that. After that, we'll be going over the IoT technology overview, one of my favorite topics. After that, I'll be explaining some use cases, and after that, I'll be going through some deployment scenarios. And in those deployment scenarios, one of my favorite topic, which is Corellian data on NMS. This use case particularly showcase the 5G connectivity and rest of it. After that, we are going to understand the integration of IoT in 3GPP standard framework. These are basic framework for industry-based levels for which IoT needs to understand and apply them in order to get them connected with outside technology seamlessly. And after that, we are going to go for the how all this 5G labs and other things play a key role in all these things. And the thing which I wanted to mention before I wanted to start this session was, I can just come here and tell you all about this AI and ML and everything, but it's my humble request to all the professors or the senior that please let your student be more indulged in AI and ML applications or something like that. If any one of your students or any one of your uh, associate is trying to make some AI ML application, and so let them try to integrate these particular AI ML this particular thing in our curriculum, because without integrating them in our curriculum, we will not be able to progress more in this particular field. Because as long as we will not be able to indulging them in our basic curriculum, I don't think so that we can study the theory part. We can make more of the projects. There will not be a particular evolution for AI/ML. So let's start with what are the basic overview of AI/ML techniques. I'll just particularly read what is written here, and then after that I'll try to explain all of it, which is going to happen in the next slides. Artificial intelligence and machine learning have revolutionized various industries by enabling machines to learn from data, recognize patterns, and make intelligent decisions. These technologies are extensively used to enhance automation, optimize decision making, and drive innovation. Key AI/ML techniques include. I'll just take a pause here. Uh, there was this great individual who was there's a great individual known as Jeff Bezos. I hope majority of you are quite familiar with it. He quoted a particular quote, which is AI/ML will not take any kind of jobs, but a person who knows AI/ML will probably take your job. I just wanted to start with this particular quote, and then after that, we're going to see what are the basic overview of AI/ML techniques. One of my favorite basic beginner level technique, which is the supervised machine learning technique. Uh, in Let me just give you a basic overview of what exactly supervised machine learning is. I can just read what is written here, and I can like give you a boring lecture and everything, but I'll try to make myself uh, interactive. In a supervised learning, the model is trained on a labeled data set. What is labeled data set? We'll get to know further. Meaning each input data point has a corresponding output. The model learns the relationship between inputs and outputs and makes a prediction for a new data. What does it mean? It means it uses a labeled data, and it generates a pattern between it, in which is there's an input and then there's an output. The particular goal in this particular supervised learning is that it's need to map to the correct output. It involves training with some historical data. I'll give you a layman example of it, exactly how it is going to work on this. I did my third year project on it, and what I did was a house prediction model. I know it is quite a basic project for anyone learning supervised machine learning, but we have to start somewhere. Basically, we will be going to consider. We are going to take some factors on what factors we are going to predict a particular house. Let it be the location, the size, number of bedrooms, and all that. And then we are going to plot a graph for it. What we have done that we have put two features, which is the area of that particular plot or something like that, and the number of bedrooms there. These kind of things and then we have just taken a historical data, which is like if consider that uh, 3 bhk is going around like 2 crore. We are talking about a good ncr posh area, in which a good 2 bhk goes for like around 3 bhk a good 3 bhk goes for like a 2 cr or something like that. Then a 2 bhk go for like a 1.5 cr or 1.2 cr. And then we are going to map an entire graph through it. After plotting that entire graph, we are going to take the features, we are going to make a gradient of it. And then after making that particular gradient from that, we are going to take another input, and then we are going to see how that particular input is getting placed in that particular graph that we have right now. I know it sounds quite complicated, but trust me, it is not that complicated in understanding all these things. The best thing about supervised learning is that it can perform really well and sometimes really bad, depending on the kind of data set which you provide. One of my colleagues also did a basic supervised learning. He had a project in which he had to detect cancer cells or breast cancer cells, and in which he would use different features, and then his model was performing really well actually uh, in detecting cancer cells in breast actually. His project was something like breast cancer detection using AI/ML techniques. He used supervised machine learning, and what he did was he paired it with a pharmaceutical company, and he asked for some data, and he tried multiple pharmaceutical companies, and then they finally, one of them actually provided him with the data, and he trained his entire model with all the features on that particular data. And at the end of the day, his model was performing really well. And I think that is where the supervised machine learning was really playing a key role in his success. Let me just give you a basic example of where we can, in our day-to-day life, where supervised machine learning is used. First of all, in your basic Gmail accounts, you must have seen that there's another section of spam emails there. What they have done is that they are able to detect what kind of emails are considered as spam and what kind of images are considered as not a spam. So they have taken a particular feature of it, they have classified, they have trained a model on it, and then they are able to classify between what email is a spam and what email is not a spam. Another one of the basic, how should I say, uh, supervised machine learning algorithm meaning is that we have image classification, in which we have cats and dogs in images, and where each image is labeled accordingly. What we have, like, we can train our model on which we have cats meow and dogs uh, bark, in which we are going to see that cats have a particular pointy ears or round nose. This is the basic understanding, like I'm trying to explain it in a really layman language. And they have a little bit of mustaches or something like that, and dogs have a little bit aggressive look. They have square eyes, they have uh, triangular nose or a round ears. And on the basis of providing all these things, we are going to able to classify if an image has a cat or a dog. Another thing which has quite there quite prominently used, which is the stock market stock price prediction model. uh, it is a part of supervised machine learning, but I will not be going to go in depth with that, because it's not one of my prominent projects. I'm not quite well versed in it. After that, I'll be going to tell you some famous supervised machine learning algorithms, which is, first of all, is a classification model. It predicts discrete labels. Example, considering if you train a model for mail and everything like that, it will be able to classify it for what is a spam and what is not a spam. And my personal project was based on a supervised learning algorithm, which was regression, in which you are able to predict continuous value. For example, like predicting the housing prices and everything like that. I think that will be like, I tried my best to explain you what is supervised learning. You might not be an expert on it, but you still got a basic overview of what it is actually. But considering that I'm giving you a basic overview in front of already who are, I think, considered as scholars, I don't think so that these kind of information which I'm providing will be a lot of useful. But I tried my best to give you a basic overview. After that, we'll be moving towards an unsupervised learning. It works with an unlabeled data, meaning the algorithm tries to find hidden pattern, relationships, or structures without predefined categories. Clustering techniques such as k-means, DB scan, and hierarchical clustering groups similar data points, while dimensionality reduction techniques like PCA, component analysis, and TSNE help in feature extraction and visualization of high dimensional data. Application include customer segmentation and anomaly detection and recommendation systems. I think majority of you will be. I think I've just just read what was written here, but let me just try my best to explain to you where and how unsupervised learning systems work. Majority of you must have been using some kind of OTT platforms, which are like Amazon Prime, Netflix. We have a lot of them. Uh, you must have seen that if you see a particular kind of TV show or a particular kind of movie, you get quite really good recommendations from just below the movie which you are watching. If you are watching some action movie, you might get some action movies under your recommendation. For example, if you are watching Ryan Gosling movies for a continuous time, you might get a recommendation as Ryan Gosling movies. If you like romantic movies, you might be getting a recommendation for romantic movies. If your search history is quite mixed with romance movies, action movies, uh, dramatical movies, your recommendation system will be filled with that only. So what basically unsupervised learning is, I'm trying to give a basic layman overview, is that it takes unlabeled data set. In supervised learning, we were taking labeled data set, and in unsupervised learning, we are going to use unlabeled data, and then we are going to basically make some patterns out of it. We are going to like sometimes, if you are not able to solve a particular problem, you try to make some patterns and are somehow able to crack it, or like you get confused even more. So basically that is the basic overview of unsupervised learning. Let me just give you more keynotes about what is unsupervised learning. In unsupervised learning, the model is given an unlabeled data and it must find patterns or structures on its own. What does it mean? It means it uses unlabeled data, data which has literally no relation between it, and it tries to predict the next outcome, the next output based on the previous data it has been provided. The goal is to discover of this particular algorithm is to discover hidden patterns or groupings in the data. It is often used for clustering and dimensionality reductions. Uh, I'll try my best to explain this also in all these things. uh, where it is used exactly, it is used on customer segmentation. What is customer segmentation? It basically, if you are an industrialist or if you are a particular shop owner or something like that, or an e-commerce website or something like that, what it basically does, it separates or it discriminate customers on basis of their spending, on what they purchase, on how often do they purchase. Are they like high value customer, or they are a low value customer, or they are a repeated customer? All these things is particularly in backend is done by unsupervised learning. What all it does, and what all the basic things which it has an anomaly detection. What is an anomaly detection, you might ask? For example, let it just consider that you are a bank owner, and as a bank owner you are seeing a lot of for fraudulent transactions uh, from a very shady account, and thus we will be able to identify it without the predefined fraud labels. And what all things might be there? It can identify topics on in collecting of articles. Let me just give you a basic example of what you can do in your particular Google search. I know Google is quite a prominent search engine. Just type anything like that. Just type let it be a beer cup or something like that. What it will do is that it will be scrapping the entire web, the entire internet, for anything related to the word beer cup. Wherever it will find beer cup, let it be in a discovery, let it be in an article in Medium, let it be an article in Times of India, all of that particular articles or that piece of information which contain the word beer cup will be displayed on your search result. That is the place where unsupervised learning takes a key role. The entire Google search engine is already based on unsupervised learning. I think I just given you a basic overview of what is an unsupervised learning. Let me just explain a basic algorithm, which is a K-means. One of my favorite algorithms actually in unsupervised learning. What it does basically is that it takes a particular output, like it can be a data set of thousand of things which have no relation with it, and it will map it on a particular graph. And after mapping that particular graph, we will just take a few points. We will take let it be a particular feature, like if you are taking, let it be uh, places which are in high demand. So you can map a particular this a graph on it on places of expensive in a particularly no particular order or no particular label. After that, what we will do is that we are going to take, excuse me, what we are going to take is choose a number of clusters, like how many clusters do we want. Like we can take 1 2 3 4, and then we are going to randomly initialize centroids. What are centroids? Centroids are basically that if a particular place, how close it is to another site or something like that. If it is little bit of closer to one site, but it is quite far away from one site, then it will cluster the particular site with one particular section. That is where the K-means algorithms takes a huge advantage. It assigns each data point to the nearest centroid based on Euclidean distance and recalculates centroids as the average of all points in each cluster. Basically, what it does, it takes data which have a similarity between each other, and it groups them in a particular in a particular centroid. I think it sounds quite complicated, but once you will study it even more, when some kind of curiosity will take place in it, in you will be able to understand that K-means is People try to make it quite complex. I mean, I'm trying to explain it also, but I think I'm making it sound complex. But mark my word, it is one of the most easiest unsupervised learning algorithms to ever exist. I think I've given you a basic overview of what is this particular supervised learning is and unsupervised learning. I've tried my best to explain to you what and how these algorithms work. After that, we are going to go with the reinforcement learning. It is one of the most uh, prominent, or I would not say highly used, but it is one of the most uh, evolutionary, I can say, learning algorithm to exist. What is exactly happening in a reinforcement learning model? I can read it, but before I tell you all this, let me just give you a basic overview. We are going to provide a data model with some particular input, and it will be generating output without any particular predefined notions or something like that. And on the prediction of those on that particular output, we are going to punish that particular algorithm. I mean, punish. We are not going to hit it. We are going to take a particular, how should I say, a point chart. If it has 100 points and it is able to make a wrong prediction, it should detect 5 points. If it is able to make a correct decision, it will increase 3 points. Uh, so basically, what should be the reinforcement algorithms be explained as? Reinforcement learning or reinforcement algorithm is a machine learning paradigm where an agent learns to make decision by interacting with an environment to maximize a cumulative reward. Unlike supervised learning, reinforcement learning does not rely on labeled data, but instead it runs from trial and error. These kind of learning algorithms usually take a lot of how should I say, time to fabricate. But once they have been developed, they are usually one of the most reliable actually, because they have been trained on a very large data set. What are the basic key concepts in reinforcement learning? Let me just give you a basic overview of that. We have an agent. An agent, it is a basic theoretical term. It is basically a model which is as a learner or a decision maker. It is deployed in a particular environment. Environment is basically the system with which the agent interacts with. The states, the current situation of the agent in the environment. Action it takes based on the output, based on the input it has been provided, and the reward. If it makes a correct prediction or something like that, it will be given a good reward. If it is not make a good decision or something like that, it will be given a negative feedback. When you will be studying reinforcement learning, you will see a particular concept of feedback signal. It could be positive, it could be negative. It is one of the most easy to base reinforcement learning algorithms to implement. And uh, let me just give you a basic overview of what it says. Like, let's just read it here. A decision-making framework where an agent interacts with an environment and learns by receiving rewards or penalties, which I just said. The agent takes actions to maximize cumulative rewards over time. RL algorithms like Q-learning, deep Q networks (DQN), and proximal policy optimization are widely used in robotic controls, robotic arms, drones, autonomous navigation, which is self-driving cars, gaming, AlphaGo, Dota 2 AI, and finance, automated trading strategies. What it does exactly, they do not assume any kind of prior knowledge of the environment, and they focus on learning a value function, estimating a future reward. This particular algorithm tries to predict a particular, it tries to predict on the basis of input it has been provided, that what the particular uh, user wants in return as an output. And on the basis of what it want as an output, it gets trained. And in this particular training, there's a feedback signal. Is there a positive feedback, or is there a negative feedback? If an algorithm provides a lot of negative feedback, it is being punished for that. And when it provides a particular good feedback, it is given a reward for that. Now there are like two ways of how should I say, two kinds of reinforcement learning algorithms, which is a value based algorithm, and second is a policy based algorithm. Value based algorithm is which one I just told you, and a policy based algorithm is basically it directly learns the optimal policy, which is uh, it basically learns what the user particularly wants, and from that it basically make a gradient. What is a gradient, you might ask? Gradient is basically a basic overview of data set which it has. A policy based algorithm has been provided with already enough data set that it is able to map what we exactly want from that particular reinforcement algorithm. Majority of you in your childhood must have used this particular AI app in the early 2009, which is the Akinator. That particular Akinator is completely based on a policy based algorithm. It is able to predict what kind of character you are thinking by just having by just having a conversation with you, and I think it is still online till today. What are the basic real world applications of it? Uh, Basically, the most prominent place where it is used right now is actually a gaming. Like, in I see a lot of this uh, gaming tech giants which are patenting particular algorithms, the reinforcement learning algorithms, in which you are able to have a particular, like I've written here actually, AlphaGo and Dota 2 AI. There was another game in which a particular player was engaging in that particular kind of combat or something like that, and that enemy was able to learn from it the user what he is doing exactly. And after the first interaction of the enemy and the second interaction of enemy will be a massive leap, as the enemy will be able to learn from your combat skills or something like that. I think I give you an idea of what basically it is. I'm not trying to diverge this particular presentation towards a gaming session, but you get an idea that the more interaction you will have with your particular that if you are like a antagonist, and that antagonist is having multiple interaction with the same enemy, that same enemy will be able to understand your actions, your combat styles, and everything like that. All thing is done by reinforcement learning. After that, one of my favorite deep learning algorithms, which is a sorry, my favorite AIML algorithm, which is a deep learning algorithm. Deep learning algorithm is basically advanced form of both all these three, and in which we are going to use multiple these kind of algorithms in the backend of it. Basically, let's just understand. I'll give you a basic overview. A subset of ML that leverages artificial neural networks (ANNs), particularly deep neural networks (DNNs), with multiple layers. These models can automatically extract features from raw data, making them highly effective for image processing. Convolutional neural network. This was my final year thesis actually. Speech recognition, WaveNet, deep speech, and natural language processing, RNNs, transformers like GPT, BERT, deep learning power applications such as self-driving cars, facial recognition, voice assistant, Siri, Alexa, and automated translations. Let me just give you a basic overview of how this particular deep learning algorithm work. Deep learning algorithm has a particular layers of a particular filtration process. So uh, you must have seen that there's a speech recognition system that it is able to understand your voice, but it is not able to understand some other voice. Or I had made a project in my final year, which was sentiment analysis. We'll go through that also. First of all, in deep learning algorithm, we have multiple layers of particular supervised learning or unsupervised learning algorithms, and our data is filtered through. It is passed through all these particular uh, layers of filtration, and after that, a final output is given in that. What exactly it does exactly? Let me just give you a basic overview. Deep learning is a subset of machine learning that uses artificial neural networks, which is in its automatically learn patterns and make decisions. It excels at handling large scale data too, such as images, speech, and text. Let me just give you a basic overview of what exactly happened is that in deep learning, let me just take an example, which is sentiment analysis. Sentiment analysis is basically if you are talking to someone, if you are able to interact with any kind of AI or any kind of uh, speech recognition system. That particular speech recognition system will be able uh, to tell your feelings, or how should I say, your mood based on what kind of words you are using. What we did in my final year projects is that we trained an algorithm based on all the words which are like based on if a person is sad, he might use these kind of words. If he is happy, he might use these kinds of words. If he is confused, he might use these kinds of words. And at the end of the day, my algorithm was like not performing till the at the level of the algorithms which have been trained by Google and all these tech giants, but it was still performing well. I was able to differentiate sentences if a person was speaking with them. He was able to differentiate that how that person has particular mindset about life, how it is uh, concluding himself and all that. I think the more I will be going that, I think the less I'll be able to explain you guys. If you mark my word, try deep learning as just a way to study it. It is one of the most best machine learning algorithms I can say in AIML. Okay, and I think I've tried my best to explain both of these algorithms. We have gone through supervised learning, we have gone through unsupervised learning, we have gone through reinforcement learning, we have also gone with deep learning. I'm just giving you a basic overview of and tried my best to make you sure that you are able to understand what these techniques are exactly. After that, this is one of the most demanding algorithms I can say, federated learning. Let me just read it. But let me just give you a basic overview what it does. In machine learning, there's a particular gradient. But what is gradient? When you will be setting some features for a ML model or something like that, you are going to get a gradient for some particular, like if you want to predict someone's particular height in a particular age group, you will be giving him a large data set and some features like if this person is from this particular background. He has some how should I say, he comes from the mountain sides, he comes from a northern plain sides, he comes from the northeast sides, and from all that you'll be giving their age. Then you're going to take an average of their heights. Just try to imagine it with me. And after that, what it does, it basically predicts an gradient actually. That particular gradient is then used as a parameter to judge what exactly is happening there, what exactly will be the next output of a particular input. But now this gradient is used in supervised learning also, unsupervised learning also, deep learning also, and in some way or other, reinforcement learning also. But where does this federated learning takes place? What it does that it does not have a centralized server. What it does is that it has multiple devices across the particular this across a particular site. And what it does, it takes those particular devices and try to understand what will be the gradient of it. I just explained what is the gradient of it, and it tries to predict the gradient of it. And after all that data, which has been provided to all the small user, the UEs or something like that, the user interface or edge devices, all that data is then transferred back to the central server where it is computed. Each of them has a particular gradient, or each of them has a particular features they want to add or something like that. You get the idea. And on the central server, all the computation takes place, and then they are finally decided that what should be the particular model on which what should be the particular gradient, or what should be the features on which that particular learning can that particular model should be trained. Truth to be told, I never was able to implement federated learning. The reason being this, it has quite a expensive project, and plus it is takes a lot of large scale integration, which is particular. Which truth to be told, it might be possible for you guys. I think it is possible for you guys because of your infrastructure and everything like that. But a particular student or a individual, it is primarily, I don't think so. It is feasible in any way. So let's just read it and let's just conclude. It is a privacy focused machine learning technique where models are trained across multiple devices, example smartphones, edge devices, and without transferring raw data to a central server. Instead, the model is updated locally and only sends learned insights back to the global model. And this approach enhances data privacy, reduces bandwidth usage, and allows AI models to be trained across decentralized networks. It is widely used in healthcare, collaborative medical research, finance, fraud detection, and mobile applications, personalized keyboards, predictive text on smartphones. It is basically, how should I say, uh, like the autocorrect on your phone is basically uh, how the world interacts with the particular topic or something like that. So predictive text on smartphone is a boon of federated learning, I can say. Now I'll be going after I've given you a basic overview of like half an hour of what is AI/ML and what exactly happens at the back end of it. Now we are going to understand the crux of the entire session, which is the AI/ML applications for the 5G. We are going to understand how particularly 5G network enhances the AI/ML use cases actually. So let's just start. The integration of AI/ML and 5G network enhances performance, efficiency, and automation. Some key applications include the network optimization. What is network optimization? AI powered algorithms optimize network resources, reduce latency, and improve bandwidth utilization by analyzing real time traffic patterns. Let me just give you a basic overview of what is network optimization. Let it be, I cannot like basically say the name, but few months back, Google was able to release its own codec, a software-based codec, which is offering low latency through multiple servers. Basically, if you like, I do know that majority of you might know what is a codec and how it functions, but I'm obligated to do so. What exactly is a codec? Is basically it's a communication device between two servers or two applications which does not work on the same uh, on the same pattern. It is able to communicate between two devices. Like, consider that if I know English, Hindi, and French, and you know English, and German or Spanish or something like that, we will be able to communicate with each other seamlessly through a codec. And so, but tech giants were able to implement codecs using AI/ML. They were able to implement AI/ML in particular codecs, and then they were able to put that particular codecs in software. They have completely eliminated the need of hardware interaction in the backend. So, like, if in future, if you are working on some embedded system, and if you are not able to see a particular codec, don't be surprised. I mean, it's just a basic jab on the tech giants, but just don't take it seriously. After that, predictive maintenance. ML model predicts hardware failures and network outages and ensures proactive maintenance and reducing downtime. This, I think, does not need much explanations. Dynamic spectrum allocation. AI optimizes frequency spectrum usage based on demand and interference conditions, enhancing spectrum efficiency. Let me just give you a basic example of what exactly it does. You must have seen that in your broadband plans, you must have seen that some plans have like high efficiency, that some plans will give you a higher bandwidth or a higher speed, but some other particular person will not be able to that's some other plans will not be able to give you that much speed or something like that, and the cost of those plans will vary hugely. If one plan is costing you, let it be 600 rupees, and another plan is costing you 200 rupees, the speed is quite vary. Like it might have come to your mind that if both of the person are on the same particular place, they might get different speed based on what plan they have subscribed to. This is where the dynamic spectrum allocations take place. AI optimizes the frequency and spectrum usage based on demand. If a particular individual wants a more or should I say, internet speed or something like that for his particular project or something like that, and he wants less interference condition and enhancing spectrum efficiency, he will be using a higher bandwidth in which a spectrum has been allocated for him to use a particular high speed internet. I think I give you a basic overview of what exactly it is doing. Let's move forward, which is autonomous network management. It is an AI-driven self-organization network sense dynamically adjusts network configuration to optimize coverage and capacity. Uh, Both of these dynamic spectrum allocation and autonomous network management, both of them are quite cousins to each other. That one cannot operate without another. The example which I gave you usually involves both the dynamic spectrum allocation and autonomous network management. What it does in other ways, it is enhances security. AI detects and mitigates cyber threats, unauthorized access, and anomalies network behaviors, and strengthening network security. Which I just give you an example. Let it be spam detection or fraudulent detection. All these things are able to work on uh, based on backend of AI ML algorithms. Now let's go to 5G edge computing and MEC, which my senior colleagues, Mr. Rishi Sani, had just taken a session. AI/ML enhances edge computing by processing data closer to the source and reducing latency for applications like autonomous vehicles and smart factories. What does it mean, data closer to the source? It is quite similar to how a particular computer uses cache machine. I know majority of you might be aware of how particular cache takes place and how it works, but let me just give you a basic overview. Like, consider that if you are computing something, a high uh, based algorithm or something like that, and that particular thing needs constant back and forth with your hard disk. What it will does, it will drastically increase the processing time. So what does cache does exactly? It takes chunks of data which it predicts that you will be needing for your next processing input, and from that it is able to reduce the processing speed. The Like, consider that if you need the hardware hitting time is 10 millisecond, and if your cache hit time is 1 millisecond, and you have 10 block cache and all of them get hit, your processing speed will will drastically reduce. This is where the 5G edge computing and MEC takes place. It is able to how should I say? It is not technically sound, but what it does is it basically acts as a cache and is able to compute data closer to the source, and thus reducing latency for applications like autonomous vehicles and smart factories. And lastly, my favorite use case, which is the AR, VR, and 5G camera. In the 5G lab, AI-driven AR, VR applications and 5G enabled cameras with face and fire detection utilize multi-access edge computing, MAC for low latency processing and real-time analytics. Now, you must have seen this famous movie Iron Man or something like that. It has multiple parts in which he had a particular hero, a genius, who was Tony Stark. He was able to monitor all that from a particular visor or something like that. He was able to have he was able to wear a particular VR and he was able to operate his entire lab. Now all these things are quite possible in your lab only. What we did was in one of the labs we were able to get the camera feed in AR VR and we were able to properly see exactly what was happening in that particular AR VR based on the camera feed. I know we are quite far away from the Tony Stark reality, but I think someday or another, if by the grace of God and everything like that, and by grace of all the good teachers here present, all the faculty members here, if they are able to uh, properly guide their students and those studying below them, that future might not be a distant future. It might be a nearby tomorrow. So I think I've given you a basic overview of what are AI ML applications for 5G. Now let's go for the IoT technology overview. I know this session is getting long, but I think I have made this session enough interactive that it might engage majority of you. Now let's start. What is IoT? IoT is basically Internet of Things. Your entire AI, ML, and everything that you can apply all the algorithms as as you want. But if you are not able to connect data from the day-to-day life or the real world, all that algorithms will go straight to vain. There's not even a debate about it. That is where the IoT technology overview takes place. The Internet of Things refers to a network of interconnected devices that collect, and analyze, and exchange data, which I just told you. And IoT technology enables smart automation and real-time decision making across various industries. Key components of IoT include. Just give me a second. Apology for that, but that for that little bit silence. Actually, I just had a sip of water. Where were we? Yes. This particular IoT, what it does is actually it is able to transmit data. I'll give you a very good examples, like two of the very few examples. I've not mentioned them in this particular PPT, but these examples are quite layman and they're easy to understand, and they're quite happening in our day-to-day life. What exactly it does is it has sensor and actuators, devices that collect real-world data, temperature, motion, perform action based on analysis. This is where we have provided the Coral GAN IoT sensor box. It is one of the most marvelous pieces of engineering which we will be basing foundation on, which is used in 5G labs. It includes sensors like NPK. NPK sensor is basically nitrogen, potassium, and calcium. It is able to detect the contents of soil. In particular soil, it is able to detect the capacity of this particular soil, the amount of content in that particular soil which has these three elements: the LDR sensor, the light dependent resistor sensor, temperature and humidity sensor, and last but not the least, and soil monitoring. It is all these sensors are used for soil monitoring for environmental analysis. Connectivity protocols: IoT uses protocols such as Wi-Fi, Bluetooth, Zigbee, LoRaWAN, and 5G for seamless communication. Just my little bit of insight here. You are not restricted to just these protocols: Wi-Fi, Bluetooth, Zigbee, LoRa, WAN. You can use any kind of communication protocol if you know how to integrate them properly. Few months back, we are working on some particular protocols which we were considering that are impossible to integrate this with the 5G network, but with a little bit of engineering, we were able to do so. I think that will be enough for the connectivity protocols. After that, we'll be moving towards edge computing and MEC processes. And MEC processes data closer to the source, reduces latency and enhances efficiency. I think explaining if I explain all this, it will not be that much efficient, as my senior colleague Mr. Rishi Seni has taken a very good session on it, uh, uh, like a few hours ago, and I think you guys are quite uh, refreshed with that particular knowledge which he has provided. Where we process the data closer to the source, reduces latency and enhances efficiency. MEC in the 5G lab supports real-time data analysis from IoT sensors, AR/VR applications, and 5G camera. And this is the basic case of edge computing and MEC. After that, we are going to move towards AI and big data analysis. Not attracts, extracts insights from IoT generated data, enable predictive analysis and automation. Before going through the basic use case and deployment scenario, let me just give you a basic overview of what we can make a use case of it. Consider that you have the Coral Yarn box, and that Coral Yarn box is connected via Wi-Fi to a particular farm or something like that, and you have deployed your NPK sensor in it, your light LDR sensor in it, your water sensor in it, your other kind of sensor in it, and it is completely monitoring the soil and everything like that. If a particular farmer, if he is well versed with the technology, if he consider all this and consider all the data which is being coming from Coral Gyan, and then he properly understand what kind of crops are suitable for that particular kind of soil, or if that particular soil is fertile or not, or if that particular land is fertile or not. On the basis of those decisions, if he is able to make a decision of which crop to harvest or which crop to uh, grow in that particular soil, it will be a much better agriculture boon for him if he is able to analyze all this data and then able to give a proper uh, guide on it and not face any kind of losses. So this is a basic example of it. Let's just see what we have right now. Smart cities, IoT enables smart lighting, traffic management, and waste management, surveillance systems to improve urban living conditions. 5G enables smart cameras and IoT sensor box, enhances security and environmental monitoring. It is basically, just imagine that if in the street lights, if the streetlights they usually have a lot of electricity dependency, and then it might cause some kind of wastage of electricity. What we can do is we can basically place a LDR sensor in it, and from that LDR sensor, if we are able to create that if a person is going on that particular street, or if a car is particularly going on that street, then street lights of that particular section should be open, and not the street lights of the entire road or something like that. After that, the thing which I just discussed, the layman example which I just gave, the agriculture, IoT driven precision farming, optimization, irrigation. These are just some fancy words, but I think I have given you a good layman example on an explanation of how we can use them. Smart homes, home automation systems, managing lighting, security, and appliances, improving convenience and energy efficiency. AI powered 5G cameras ensures real time security monitoring. After that, we have the automotive and transportation. What is automotive? Before, I think I've just jumped a topic. Let's go back to the smart homes and what it does exactly. The smart home appliances are like no longer a prominent use case according to me. They have already been deployed and are being used by really good architectural marvels. What exactly smart home is basically, if you are going on a in your particular house, it should be able to particularly use that. If you are holding the handle, it should be able to recognize your fingerprint and recognize that you are the owner or the person who is living in that particular area, and that information is that information is given to a centralized server, and it is able to predict that you are the person who is living in there, and then he will unlock. Then that particular server will give the command to unlock the door. All that if you are particularly using a light in one room, and if you have just exited that room and forgot to close the lights, that particular how should I say room should close the lights by itself, considering that you are no longer in that room. I think these kind of things are quite prominent nowadays. If we go to some of my colleague's house or someone like that who is quite doing well in life, you will see that these kind of things are quite already applied in his day-to-day life. After that, let's go for the automotive and transportation. IoT powers connected vehicles, fleet management, real-time navigation, enhancing road safety and logistics. Basically, what it does is that it is able to communicate between two vehicles, and they are able to move with each other seamlessly. And after that, we have industrial IoT, which is also known as IIoT. I don't know why. IoT enabled manufacturing plants uses smart sensor and real time analytics for predictive maintenance and automated operations. These are also quite prominent use cases of it. And then we have the healthcare system, which is IoT devices enable remote patient monitoring, AI driven diagnosis, and real time emergency alerts, and improving healthcare and accessibility and efficiency. The those things that we used to see in futuristic movies such as Blade Runner or Blade Runner 2049 or something like that. These kind of things are now quite possible with 5G and all this AI-ML techniques. These are all the basic use cases. I don't think so that I have emphasized enough on each of them, but I think you get a basic overview of what exactly they are. And I think all these kind of things, I I don't think so. I know that all kind of these things are all these kind of things all these kind of things are quite possible with all the equipment we are provided in the 5G labs. This is a basic overview of one of the how should I say a use case which we have deployed in a 5G lab. Basically, what it does is that it is a basic architecture. I have designed this entire basic diagram with myself only, and what it does exactly, it is able to transmit data from one particular site to another site, and we are able to see that particular data on our NMS. Let me just give you a basic overview of what it exactly does. Coral Yarn, which is an IoT sensor box, it has sensors like multiple sensors. It has the LDR sensor, it has the temperature humidity sensor, it has soil sensor, and plus it has how should I say support for multiple other sensors also, which can be used by your students or your colleagues or someone who wants to commit to good research. Possibility of future sensors is already there in Coral Yarn. This Coral Yarn does not have a transmitting capability, so it is connected to IoT gateway. This connection is usually established via Ethernet, and this IoT gateway is able to monitor that particular data of Coral Yarn, which is coming from the IoT sensor box, and it is able to transmit that data to 5G radio. What that 5G radios does is basically just this 5G radio communicates with all the devices which have particular SIMs in it. Like the CPA has a SIM, the IoT gateway has a SIM. Those devices that does not have a particular SIM in it will not be able to communicate with the 5G radio, and thus will be needed to connect it with a particular device which do have some communication with the radio for in order to transmit data seamlessly. So what it does exactly, this IoT gateway transmit data to the 5G radio. This particular communication happens via 5G SIM, and this 5G radio is connected via the 5G core and NMS via Ethernet on the backend. What this particular thing 5G core and everything like that they do is that they take that particular data, analyze it, and then give a particular response to it, what it will do. Then that particular 5G core and NMS transmit that data back to the 5G radio, and this particular 5G radio transmit that broadcast that particular data. And what that after broadcasting any kind of equipment which you have connected with the radio, they will be able to see that particular data via the 5G core. If you are like if you have a UE, or if you have a EV board, if you have another UE, if you are connected by the Wi-Fi of the evaluation board, if you are connected with the IoT gateway Wi-Fi or something like that, you will be able to access that data. After that, for this particular example, we have then connected the communication establishments via CPE, which is premises equipment. And this particular premises equipment transmit that data via 5G, which I just told you, like a Wi-Fi. And if you are able to connect with that particular Wi-Fi, then you will be able to see the data of Coral Yarn, the LDR sensors data, the 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 ratio of nitrogen, potassium, and phosphorus data in particular soil or something like that. You will be able to see all that data on your computer system, or if you're connected via, if you have a small UE, or if you have a small mobile phone, and if you're connected with this particular 5G Wi-Fi of the CPE, you will be able to see that particular data. I think this explains a basic overview of how communication happens via 5G and IoT based system. This is just a basic overview of what I've just explained to you. Coral GAN data on NMS communication flow. I think I've just explained the entire. Sorry, I've just explained you the entire communications flow and how the architecture works. But let me just read this out as a basic formality. A step-by-step communication flow. Coral GAN, which is the IoT sensor box, it collects the data and transmission. It is responsible for transmission. IoT gateway, which is the 5G radio transmission. The IoT gateway acts as an intermediary between the sensor box and the 5G network. It aggregates the sensor and forward it to the 5G radio when it detects an active 5G connection via 5G SIM. That 5G radio gives that particular data to 5G core, and then transmission takes place. The 5G radio, also known as the G Node beam by far more technical individuals, it receives that IoT data from IoT gateway. It then transmits data to the 5G core, and the 5G core handles the authentication and routing and everything. 5G core, then 5G core to NMS data forwarding. The 5G core forwards the received sensor data to the NMS network management system, and then NMS is hosted on a cloud or an on-premise server and processes, stores, and visualizes the entire data. Data can now be monitored through an NMS dashboard. This is the basic overview of how the Coral GAN works with the NMS actually. I tried my best to explain to you both in a theoretical way also and in a layman way also. So there's also a concept of reverse communication flow also, which is from NMS to computer-wise 5G. 5G radio connection to 5G CPE. Where a 5G CPE device is connected to the 5G radio via 5G SIM, it acts as a bridge between the 5G network and local devices, PCs, IoT devices, and etc. The 5G CPE receives data from the 5G radio and establishes an IP network for connected devices. And 5G CPE to computer system transmission. Any computer system, IoT device, or local network connected to the 5G CPE can now access data from the NMS dashboard. The data can now be accessed via web interface, which is the Coral NMS, by the default IP of 192.168.11.35. Just make sure that this particular IP, the third octet of the IP address, make sure it is based on the series which has provided to you, which is quite similar to your side. Like if you're some other side, it has the third octet might be some different series for you, but your 35 will remain constant as we have programmed it for like that only. So it is easy for us to get training. But for using it for other devices, you can use setting by setting it at DHCP or static. This is just a basic insight of how Coral exactly works. Now, these are particular standard frameworks on which IoT integration usually should take place. The third generation partnership project, the 3GPP, plays a critical role in defining standards for cellular IoT integration within the 5G networks. Basically, what we have to do is that all these IoT applications, they do need some global policies or protocols in which they need to be integrated in a real world scenarios. Let me just go through it, what exactly it is. Massive machine type communication, MMTC, supports large scale to IoT devices connectivity with minimal power consumption and essential for smart city applications. Ultra reliable low latency communication, QRLNC, ensures real time data transmission for mission critical applications like autonomous vehicles and industrial automation. NB, network in a box, IoT and LTE provides low power wide area connectivity for IoT devices, improving battery life and coverage. Network slicing allocates dedicated network resources to different IoT applications based on priority and requirements, ensuring optimized performance. And security frameworks implements end-to-end encryption, authentication, and secure provisioning for IoT devices in a 5G network, ensuring data integrity. From all these particular frameworks, I think most of you will be able to relate with all the examples or all the layman examples which I have provided you, and all the basic uh, scenarios which I have just explain to you, you guys will be able to relate it on 1:1. And now at the last thing, the 5G lab and emerging technologies. All these all these technologies and everything uh, will now be able to integrate it with a particular 5G labs. All the things which I've just told you in this particular session about the AI/ML, the IoT integration, everything, I will be able to take place in real world with the 5G labs which we have provided. The leading technology firms and research institutes are establishing 5G labs to explore and test AI, IoT, and 5G synergies. These labs focuses on these particular things, which is 5G enabled smart cameras, remote healthcare, AR VR in 5G, which I just told you, IoT sensor networks, which I just gave you a layman example, and also explain the entire architecture with a particular diagram. Massive device connectivity, when the CPE uh, was broadcasting the NMS data on a particular cloud, it was able to connect devices through it, and AI-driven network optimization, which I just gave you a basic codec example of it. These are all the basic emerging technologies, according to me. And truth to be told, with the 5G labs, the emerging technologies, sky is the limit for all the innovation and research. Truth to be told, these advancements highlights how AI, IoT, and 5G will continue to shape the future of connectivity and automation. So, guys, thank you for your time and patience. I really hope you enjoyed this particular session. If you need any kind of doubt or anything like that, I'll be more than welcome to answer it.
And IoT in 5G. You can contact us. You can ask now also. Please, Tushar. So that is all about today's sessions. Tomorrow, actually, there's a main component is going to be happen. That is evolution board. So that is morning 10 to 2. I think already got the schedules of that. And please ensure that please attend that session because the evolution board is more important to modern in these 5G use cases. So I hope all enjoy this session and we can continue with tomorrow morning. Um, so, sir, we can we conclude? So, sir, can we conclude?
Yes, hello. Yes, yes, hello.
Yeah, fine, fine. So
Conclude.
tomorrow that first 10 o'clock that evolution board will be taken as a first thing. Okay.
Okay, okay,
So
okay.
okay, thanks a lot, sir. We'll see you tomorrow morning. Thank you.
Okay, thank you, thank you.